My name is Felipe Cruz. I work at CSCS, ETH Zurich. And today I'm going to talk to you about FirecREST, RESTful API for HPC. So first, I think I need to introduce myself a little bit so that you know my background and what I'm talking about this project to you today. I'm the lead for the FirecREST project. I've been working on FirecREST for a good part of the last few years on making this interface for HPC computing. As a technical lead, basically, I have a full view of the whole project, and I can give you all the details that you might want to know. And the idea for this presentation is that first we take a high-level view of what FirecREST is and what is it built for. Then we will jump in and out of these different levels of details so that you can be familiar with different aspects of it. So first we're going to start high, then we'll go into details as we progress into the presentation. And as a disclaimer, this project has received some funding from EuroCC, and this is helping us bring you some of this training material to you. Okay, so table of contents is very straightforward. So first, I'm going to start with the why. Then I'm going to give you a very brief explanation of what FirecREST is. Then I want to show you the API itself. So we're going to browse through some of the documentation. Then I'm going to discuss some of the key capabilities. So from a technical point of view of what the API can do for you and what it's doing internally, so that you kind of understand why FirecREST, what FirecREST does behind the scenes to bring you value. And at the very last part, I have some demonstration material where I want to show you some, let's call it live coding. So hopefully that will go nicely. All right, motivation. So why is it that we started looking into RESTful interfaces? This is even before I tell you actually what the project is doing in a little bit more detail. So just so to get the context of where the need came from. So what we were seeing at the center was that we were seeing projects and users that had the need to integrate HPC into advanced workflows. So they needed to use HPC tools within some of the applications or workflows that they were working on. And we started to see a proliferation of custom solutions, meaning that they had, each of them were implementing different ways to connect to the cluster and then to the supercomputer and then do different things on it, mainly submitting jobs, interacting with the file systems. But you can imagine that if you have, N projects or X users, and each of them had a custom solution, then we had to support a lot of different workflows. And every time that maybe a change happened on some of our back services, or maybe the user wanted to implement access to something slightly different, then it was challenging for them because they had to implement the way that they connect to our infrastructure. And it was challenging for us because when we were, implementing, upgrading a system or changing a service just a little bit, this might mean that these workflows might break. So that was not good for anyone in the long term. So things work, but you can see that this solution of having so many ways to do something doesn't scale and is complicated for everyone. So it was clear that we needed an interface to HPC resources that was standard and modern. And then the kind of things that we were seeing that the interface had to do was to be able to access HPC clusters. So that means the job scheduler, to do file system operations, to be able to move data within file systems, and to be able to transfer data in and out from our infrastructure. Then one of the let's call it soft requirements. So was not really a hard one. Was that the interface also needs to integrate. So this is from our point of view. It needs to integrate with our current HPC infrastructure. So what this actually means is that we didn't want to, when we were solving this problem, we didn't want to build a new secondary infrastructure just to serve the needs of this particular interface. So we had to use the different services that we already had in place. So build on top of what we had. So hopefully with this, you have a clear idea of where we started and why we were moving forward initially here. So now in a nutshell, what's FirecREST? So FirecREST is a web-enabled API to HPC. What this means is that you can access HPC resources via the web through this API. And the idea that it provides is that it abstracts, it uniforms, and standardizes the communication between a web client and HPC service and the resources. Now, a web client could be a cell phone application, like a web app that you could be running on your phone, like a native phone app, or it could be running on your browser, on a computer, or on a server. So it gives you quite a bit of flexibility on what kind of experience you want to implement for your users. And what it basically does, it's rather simple, the whole concept, is that it's going to, FirecREST is going to receive web requests from your application. It will translate that request that comes in web format into HPC business logic, meaning here the backend operations that we do on our infrastructure. The infrastructure will respond. Let's say you want to submit a job. So you make the request in web format about submitting the job. You need to pass it to the schedulers in the correct format on our business logic and to a particular cluster that it needs to run. The cluster will execute that, and then you will get a response. Generally, that response is not on a web-friendly format already because HPC cluster talks Linux and the web doesn't talk Linux. They have a different set of tools for communications there. So we need to parse back. So FirecREST parse back the HPC results and then put it into a format that then your web application can readily use without too much work. So this back and forth between the web world and the HPC component is what FirecREST is taking care of for you. Now, it also does in a way so that it ensures to the people, so to the users and the developers, that every request is being properly authenticated and authorized to access the services. And it does so in a way that we make sure that the security chain of the whole conversation that is happening between the web applications and the HPC backends is not broken, meaning that FirecREST doesn't have superpowers to do things on behalf of people without, let's say, by skipping rules or taking advantage of it. Actually, it's built in a way so that only the people only the users that are requesting the operations are the ones that can execute their commands. So the idea is that we don't break that security chain. And here on the bottom right, hopefully you can see my mouse pointer. We have the FirecREST logo. So that's something that you can recognize as us now. So is it more or less clear what is FirecREST in a nutshell? So from a very top level, if you have a question, you can point it out on the Q&A box, and then we will try to answer it as we go. I don't see questions, so I move forward here. Okay, so first, in a nutshell, that's what I wanted to tell you very abstractly. And then in order to make it concrete, I want to show you an example of what such a client could look like. So basically what you're seeing here is a server web application. So this is a web application that is running on a server. We built this to show a complex workflow that could be representative of what a user might want to do. And in this single web portal, we're doing several things at the same time. So let me break it down for you from the top level. So in this web page, you already have, you are logged as a particular user on one of our systems. We're going to, we are showing here all the jobs that are running for this user so that you can monitor what is happening on your system, on the system that you're accessing, in this case was Daint. And that's the top half. Then in the bottom half, what we had was the implementation of a workflow. So basically we have a CFD application that was containerized, and we were able to submit a job that will execute this complex application on behalf of the user via the web portal. And basically what you see here on this panel on the left-hand side of the submit job was to control some of the parameters of that simulation. In this case, it was related to the parallelization. So the number of nodes that we were going to use for running the job and the number of steps of the simulation. But this could have been completely customizable in the sense that we could have also selected, for instance, input parameters or some other kind of relevant scientific parameter for any particulation, really, for any application, really. Then on the right-hand side of the bottom half, we were showing the results of what we were executing. So basically on the portal, you could select your parameters, submit a job. The job will start queuing on our infrastructure. And then as things were progressing with the results, here on the bottom right, you will show some of the progress of what the application was achieving. And in this case, what we were doing was basically taking snapshots of the simulation as it was moving forward, and then making those available back to the browser so that you can see, let's say, kind of real-time the simulation progressing. So in this case was the fluid flow over a cylinder. So this is the very classic vortex sharing experiment. And you could see it actually animated using some GIFs with some post-processing that was happening. So there was another button here where you can post-process the results as the different jobs for the segments of time steps that we were running. So to put all the snapshots together and then give you an animated GIF of what was going on. And we were then rendering back this on the web portal. Okay, so that's kind of the meta. And all of this was enabled with FirecREST, but what exactly then was FirecREST doing in this little application that we built? So first we were listing jobs for the user. So we have some intrinsics for listing jobs. Then we have some calls that allow you to submit a job with different parameters. So we were creating an S batch and submit that to our cluster on behalf of our user. Then on the working directory, we are able to list the files, actually create directories and list files for the experiment that is actually running. And as we are listing them, so with every query, we can refresh the information that is being provided to the on the web portal. And then we were submitting a further job for doing some post-processing. That's what this button does. And we were retrieving then files directly out of the cluster and then rendering on the web page. So then you can, I think with this explanation, hopefully you can see what were the components that were being enabled by FirecREST. So submitting jobs, listing, executing jobs, the ones that are currently running and the ones that were completed, listing files, creating directories, retrieving files from the file system. And this was just a demo application that it was built in a few hours. So it didn't really take much time in order to develop this. Most of the effort was related to putting it together nicely on a web application, basically. I see that we have a question on the Q&A. So the question is from Leopold Talliers. Hopefully I pronounced your name correctly. So Slurm ships with a built-in REST API since Slurm 20. Is FirecREST interface to the Slurm REST API, or does it use the command line interface? Okay, so it's true. So Slurm implements a RESTful interface since Slurm 20. We actually had a try of that version, and what we found that it was not quite ready for production yet. So even though they're progressing that in the general direction of having the interface up, there are still aspects of it that are not ready for the integration at the level of what FirecREST needs. Now, eventually, what we hope it will happen is that as RESTful APIs matures for vendors for HPC vendors, FirecREST will stop providing the backend logic of being able to give you access to those services, and it will just help integrate the different tools together in order to provide that feature. Okay, a different question from Leopold again. So he says, you mentioned the need for standardization. Besides CSCS, which other HPC centers were involved in the design process, and which of them will adopt FirecREST? Another good question. So we are actively engaged with other sites that are looking at the same issue. I can say that the interest at the moment is very green. So I think that the people can recognize, so from different sites, that there is a need for these kind of tools, but they are not necessarily on the, pushing the topic on how to resolve this. So FirecREST is one of the few projects. It's not the only one that is trying to tackle this issue, but I think we're one of the projects that is trying the hardest. And part of the activities that we are pushing for is to start these conversations at a wider HPC site level. So we're discussing this. We're taking RESTful APIs to conferences at venues where these kind of points are actively discussed. Now, interestingly, I think that FirecREST has also helped other sites as an inspiration on how to implement these interfaces. Now, eventually, the long-term goal would be to converge towards a particular set of interface calls that we can all use together. But I think we're still a little bit far away from that solution. And I also hope that part of that solution will come from vendors. But it's a little bit of a chicken and egg kind of problem, where the people cannot build applications because there are no interfaces unless you're very, very motivated. And vendors don't create interfaces because there is no people with applications. So we're trying to bridge that gap between the current situation and the future one with some intermediate solutions. Okay, third question. So I'm being asked, is FirecREST supposed to supersede Unicore? Not really. These are different efforts. So we're trying a different approach to what Unicore is doing here. We're actually proposing a different type of interfaces and architecture, really, to what Unicode does. And hopefully through this presentation, you'll be able to see. So one thing is that you see that from the user point of view, what you really care are about the interfaces, so that you can interact with the infrastructure. But from sites and technology providers' point of view, it's very important how this integrates with your infrastructure. And there is a lot of work done on that aspect of that integration. So even though maybe RESTful interfaces look just the same, more or less, from an abstract point of view of what you want to do, actually how that gets implemented and integrated with the infrastructure is really important. So as I mentioned very early on, the idea is not to, for instance, one of the principles of FirecREST is not to create a secondary or parallel infrastructure in order to provide the services, but to try to rely on the infrastructure that you already have in order to run it. And that integration actually is quite tricky and nuanced, and a lot of work has gone in that sense. So I guess it's kind of a complicated question what you're asking. And it really depends on maybe the point of view of each site on how they want to go about that. But I hope that in the long term, we can converge toward just the interfaces. So it wouldn't matter so much if the backend that is answering your request is one library or one project or the other. Hopefully I gave you a more or less idea of where things are going there. Okay, so let's continue with the slides. Okay, so basically I show you the web application from the point of view of a user. So what I want to show you now, it's the point of view of the developer. So what I want to show you here is basically how we created the table on the top. So just for listing jobs. And I want to show you how easy it was to do with FirecREST. And this is just a snippet. It's more or less the same for other subcomponents of this web page. So basically what you see here on the left-hand side is the HTML code for the table that was listing the jobs. The interesting part really is that we were using a standard HTML, and we were pointing out the data URL, so whatever is being fed, so a JSON package that is feeding the data that goes into the table, we're pointing out to the list jobs endpoint, which was part of the application that we built. And then on the implementation of that, we did with a Flask. So the Flask backend was just implementing the list jobs. So this is a code that you see on the right-hand side that was responding to this request. So this is the guy that's doing the FirecREST, the handling of the FirecREST interface part. So here we're using a Python library that we built for FirecREST. It's called FirecREST. And it allows you, it really simplifies the workflow of talking with the FirecREST backend. So there is some initialization at the beginning, and from there on you could use some very basic codes in order to obtain different types of information. In this case, what we are showing here is just the list of jobs. So we are using the library here with the FirecREST client here. We're polling the system. So in this case, we're polling DOM, and we're trying to retrieve the jobs that are coming in. And basically, this is what you're getting out of here is a JSON list directly out of the system with the jobs listed for your user. This already being authenticated, and through this authentication is how we get the user that the request is going for. So in the case of the example, So in the case of the example that we had, the user was Irini, and then because she was authenticated via OIDC, FirecREST is able to know that and then request the jobs on her behalf. Then on the Python code, we just get the JSON list, and yeah, if it's not empty, then we send it. That's basically the whole logic that you see here. So it's kind of rather simple. Hopefully with this now, I gave you some, so I went from something very abstract. Now I show you something very concrete in terms of what you could do from an API. Now I give you an example of something very particular on how complicated it could be, which hopefully is not very much, how to interface with this. We're doing it with Python, but because we are built on top of standard tools, and this is a RESTful interface, basically any programming language that has a web request library, then you can build your own simple clients in order to interact with the API. So here we go into the API. So basically what I want to show you now, it's the API documentation. So if you give me 1 second. I hope I can do that. Let me see. I just did, can I do this? Great. I have VPN problems. Let me check. I did not lose you because I cannot see. Can you raise your hand to make sure that you're still there? And I did not lose network. Okay, you can see me. All right, cool. For some reason, I had some network problems. I tested this like 1 minute before we started, so I guess this is just, yeah, okay, that's bad luck. It's a good thing then that I decided that just in case that happened, I was going to, I took some screenshots of the API documentation, so I can show it to you. It's kind of a bummer because the documentation is actually very nice. So let me see if I can do one more try of, wait, I know what it is. I know what it is. Just 1 second. Yeah, I think that's it. Give me 1 second. I need to share this other screen. So I'm just picking it up. Let me share. What? Okay. No. Oh, man. I don't know. It doesn't want to. Here. Okay. I don't know. It just took a little bit of time for Zoom to pick up the screen. No idea why. Can you see now this web page with the API specification?
Yes, we can.
Okay, thank you very much. So what you see here is the Swagger client. It's basically a tool that allows you to render OpenAPI specification. And what we have here is the full specification of FirecREST on all the microservices that are provided by the tool. So we have a bunch of them, as you can see. So I will browse through it very quickly and maybe stop on 1 or 2 in order to show you things. So what we have is a status. So with status, you can see what's currently going on with the system. So we can tell you what systems are available, and you get information about the parameters and the responses that you will get out of the queries. You can list different services that could be running. Currently, in this case, is related about the health of the internal microservices. So in case you're trying to query utilities and for whatever reason it's not responding, you can check if the service is actually up there and running, and you will get information about that. Talking about utilities, utilities is a microservice that allows you to So we implemented with microservice architecture. So this set of tools allow you to do different type of file system operations, and you can list files, create directories, rename things, change permissions, create symlinks, do some small file downloads or uploads when you need to operate with let's say less than 5 megabyte kind of files type of operations. So that's utilities. Can I do this? Yeah. Then we have compute, which allows you to upload job scripts and execute them. You can also query what's the status of the different jobs that you have. And for instance, the compute jobs will retrieve the list of all the jobs that are currently running on your system. And we interface with those. So that's one example of what compute does. Then we have a storage that allows you to move data internally within the center, so between the different file systems that we have, and it does so with high performance. So imagine that you might have several tera or petabytes of data, and you might want to do a copy or a move or something like that. That could be a substantial effort to do, let's say, interactively via the call. So we have this other set that is a non-blocking set of API calls that allow you to do those operations. We also provide some external, so data transfer operations that allow you to move, to upload and download files, a very large amount of those through object storage backend. In order to track the asynchronous aspects of the operations, we have created these task microservices that allow you to track the different things that are going on. And we also provide some endpoints in order to interact with reservations. So very briefly, that was an overview of the API. And as I mentioned, we have fully documented each of the interfaces with parameters and outputs, so that you can implement the proper logic on your application. Okay, so moving on. Wait, I need to share back then the I think it's this one. Yeah. Okay, so that was the API. Now, very quickly, I tell you about the key capabilities. So let's say this is what makes FirecREST different from other applications. So from similar tools or just other set of applications in this domain. So as I mentioned before, this is a web interface for classic HPC, and it works as a bridge between the web applications and your HPC infrastructure. So the idea here is that while the vendors, they're working on building their interfaces, which might take some time, then we have a bridge that could, work while the future happens or while we get there. So that's what FirecREST is doing. It's also agnostic and interoperable. So what it means here is that we're using standard tools, standard web protocols, and by using REST technologies or HTTP, it means that pretty much this is platform and programming language agnostic. So you're not tied to, let's say, Python or Go, or this should pretty much work with any programming language, as I mentioned before. We integrate with HPC via a standard cluster tool. So in case you are interested of running a tool like this on your own infrastructure, so you have a cluster or so, the kind of integration points that you actually need is basically that your cluster talks SSH. We use then SSH connections in order to oh, I forgot the word, to delegate the execution of requests on behalf of the user. Very importantly, we also secure and protect the usage of resources, and we do that with several technologies. One of them is Open Policy Agent that allow us to implement fine-grained rules for different set of conditions or contexts over which you can end users, web developers can control the access of the resources of the infrastructure, and we are actively working on this aspect still. We also provide some monitoring and logging. So pretty much everything that is being done via FirecREST, you know, we can control it, and that gives you some let's say peace of mind that you know, just by using FirecREST, you are not opening a backdoor for your, you know, the resources that you actually own. So this is important aspect of it. The end-to-end format mapping here means that while we are integrating with the infrastructure, FirecREST is the one that is taking care that the tools that you are talking to, they are responding you, or they're giving you information back on the correct web format, so that you don't really need to tweak too much in order to integrate with the infrastructure. And we're also doing some service orchestration. So some of the calls that I just showed you actually are doing several things on our business logic, and we're taking care of that for you behind the scenes. So for instance, when you're doing an upload and we're using a staging area, then there are some several things, data movement, creating of some object storage, temporal object storage, and the whole coordination of that is being done by FirecREST, and hopefully more or less transparently, so that you just can you know, use the high-level interface and not deal too much with the details. And let's see. I want to do a demo. So I know that there is one more question, but I would, is it fine, Thomas, if I answer this at the end, so that I have time to answer your question towards the end, just to make sure that I don't run out of time with the demo part. Plus, there is still the chance that, you know, the demo gods will not be happy, and then something will break, and then in which case we will have plenty of time to answer that question. So let's see. So what I want to show you, it's a piece of code that, oh wait, I need to share the screen. I think it's this one. Let's see. Okay, can you see my terminal with the two panes?
Yeah, it's visible.
Okay, excellent. Hopefully it's not too small, right? It's legible.
If it's possible to increase a bit, might not be too bad.
I think if I do the opposite, like if I shrink it, then did this help? I think so.
Yeah, I would say it's readable.
Okay. Okay, so what you see here on the right-hand side, it's a very, very tiny web app that I built with FirecREST. Basically, the FirecREST library for written in Python that interface with FirecREST. Basically, needs a little bit of information in order to connect with your infrastructure, and I put all these, you know, all my secrets and stuff on my environment variables, so that you don't get access to my client credential information. But pretty much it's the same. You need a client ID, client secret that basically allows you to authenticate, so a way to get a token. And then basically what happened after that is that FirecREST is expecting for every request that you're sending for the request to come with authorization, with an access token. No, not true. With an authorization token. And this is basically a JSON that describes that you are properly authenticated, and you can actually access the endpoints that you're trying to access. You do that by talking against an authorization server, and this is basically what this line of code is doing. So it's passing my credentials, the client credentials, to the server. In this case, I'm using the client credentials, so it's a little bit of a shortcut that I took, but I don't think it matters much in the big picture. I have a small supporting class that allow in order to get the access token for this. Now, this is a little bit of technical jargon of what you need in order to use OIDC, but I think what really matters here is that we have a way to authenticate, and this is what is happening here. Then we're telling the library that we're trying to connect to FirecREST, so I pass the FirecREST URL, and then I'm passing the mechanism in order to get the access token with my credentials. So this is basically all of this, so pretty straightforward so far. I have a helper function that allows me to print a little bit more readable JSON files. And then I'm going to show you like some simple codes for a bunch of stuff. Now, I implemented this very simply, in a simple way. So I'm assuming that all my responses are always correct. And if you remember my very brief demonstration of what the API looks like, each of the requests will provide different responses depending on what actually happens. So for instance, if you do an ls and the directory doesn't exist, then it will respond with an error because that's with a HTTP error. And the library in this case is going to raise the error that it sees, in which case you need some error handling in order to properly implement this. Now, I have not done properly because I just want to show you how the basic code looks like. But I guess that you're able to get the idea of what's happening here and how you could use this tool. So, okay. So you're already authenticated because that's basically what happened on the previous step that we have here with FirecREST. Now, if you imagine, for instance, you want to get all the systems that are currently available via FirecREST, you can list them via the client. So you just say, client, please give me all the systems. Or you can also ask, well, I also want to get all the files. So basically, I'm doing an ls into a particular directory. And interestingly, well, if that directory doesn't exist, then it responds with an error, and then you can handle that particular case in your application logic, for instance. You could go then and create the directory, in which case the next time that you ls it, the directory will be there. So it should be able to pass and then run through. And finally, you might want to submit a job. In this particular case, the only thing I need to do is just to pass a bash script and it will do it. Now, if you want to see how it will look if you are handling a little bit better the exceptions, we actually have some exception handling, and this is more or less what your exception handling will look like. Now, what we're doing here is to get the parameters of FirecREST. I will explain a little bit more detail that once I show the output of all of this. So hopefully this will work as expected. So I tested this before. We should be good. Yeah, so now the application is talking with FirecREST. And I'm getting responses. So let's go over what I got, because basically my code was doing a lot of things all together. So the first thing we did was to get the systems. So currently Daint is available via FirecREST. The second thing we did was to request for a directory that on purpose didn't exist. So I just named that some random number then, and then random, not so random number that I knew it didn't exist. I request for that, and it would say, well, contents don't exist. Then I created the directory that went fine, no errors came in. And then I'm listing the files within that directory, and well, the directory is new, so stuff is empty. That will be a JSON list with all the files and a lot of information about the files that will come back from there. And then I'm submitting a job. This just went through because the job was queued. So the response was trivial here. And at the very end, I was asking for the parameters of the cluster that I'm accessing. And here gives you, actually no, the parameters of FirecREST. So here gives you information about the kind of things that you could do. In this case, for instance, what is the expiration time of the temporal URLs when you're doing large transfers in and out of the object storage. And this is this very large amount of time because we expect that you do very large transfers. Some other information about the available file systems and what is available on the utilities microservice. So hopefully with this, You could see that if you use a library like the Python library that we have, it could be very easy. But if you don't want to do that, you want to have more control over the nitty-gritty of what's actually going on with the API, you could go directly and talk RESTful codes to the FirecREST backend itself via whatever programming language you might want to be using, depending on your web application backend. Then going back to the presentation, because that was demo time and it went fine. I leave you with some further material. I would just leave it here where we answer the last few questions that we got in. So okay, let's see. Thomas Vieira is asking, sorry if I mispronounce your name. There's a lot of endpoints in the API. Do they operate on abstracted paths, or does one need to know the actual file structure inside HPC in order to use those endpoints? If I switch to another HPC that also speaks FirecREST, do I also have to change the parameters that this calls to match the internal file system structure of that other HPC? Yeah, so basically the utilities endpoint gives you access to the POSIX file system. That means that basically in order to interact with that, you need to query it in the same way that you normally do via terminal. If you wanted to do something that is more abstract than that, then I suggest maybe using some of the object storage infrastructure that is also available, but it's not, fully integrated with FirecREST. But you could use, let's say, S3 interfaces or Swift interfaces in order to do something that is a little bit more abstract. That would be my answer here, depending on the needs. So this actually depends on the needs. The idea of the utilities endpoint is really for you if you need your to operate for particular jobs. So for instance, if you need to set up an application that you want to run, you need to do some preparations. Like for instance, the application might expect that some files might be on a particular location, or might expect that some other kind of information is available there. And these tools, like tree structure or whatever, and these tools allow you to interface with the file system in a way that you can actually do it. So that you don't have to put all of that, let's say, in a job script or something like that is less transparent. Hopefully I answered that. So now I see a question from Eduardo. Is accessing using FirecREST still in private beta? If not, how to get access? Credentials for a CSCS account. This is a good question. So no, FirecREST is in production. But it's in production beta. So what this actually means? What this actually means is that the whole infrastructure is in production. We're still working on some aspects of our authentication infrastructure, so of our IAM. What this actually means is that we want, if we were to do general availability of this tool, we will need to sort that out, but this is something that we're actively working on. In the meantime, if you want access to FirecREST, you can send an email to support, and then we can sort that out for you if you want to try it out. But the infrastructure itself and the endpoints are available for the needs if you have any. So please do send us a request to support if you're interested. Let's see. We have another question from Leopold. When I use SSH to log into a cluster, I can do so from any computer. Do I need to have a static IP address in order to register as a client with FirecREST? Okay, so the context of this question is related to our IAM layer. So Leopold, was probably around when we were discussing FirecREST maybe over a year ago. At that time, the only way to have a OIDC client was via something that is called code grant flow. And that OIDC workflow, sorry, it's a little bit technical, but I think I need to just jump in very quickly here. So that workflow actually requires to set up a back channel, a secure back channel between the authorization server and your web application. That means that when the authentication step takes place so that the user can log in into our authorization server, the authorization server then will send the information of the successful authentication, let's say, back to the web client. And in order to send it back, you need to have a static IP so that the website, the authorization server can actually find your web application. Now, the reason that that workflow was like that was because we had the code flow was the only one that was available then. Now, so since then, there are other options that are available, and there are a few more that are being explored that do not need to set up that back channel. So, for instance, it's possible to set up the client's credential workflow, where you could have a particular account binded to some set of credentials. You could use the authorization ground flow with Pixie if you wanted to have something that is a mobile application, for instance, where you don't have a static IP. So all that complicated answer was to just let you know that now there are more mechanisms, and that requirement of this static IP is not a hard one anymore. So there are options that are available, and there are nuances that put some constraint of which one you should use or what conditions. But we're happy to talk about those on more details. We can do it offline, or just send me an email, or we can do it over support. So I guess that's good news, no? So that's not the only way to do that. So you don't need a static IP only. Any other questions before we close? If not, I thank you very much for your attention, and I hope now you have a more clear view of this service that we have now in production, and how it could bring value to your daily work. I don't see any more questions, Matthias, so I don't know if you want to say some closing remarks, or maybe we just close it.
No, I think you said everything. So I think we can wrap up here.
Thank you. Okay. All right. Have a good day then.